we have the graph of a polynomial on the left, and we're told that we want the equation which produced the graph. So this is fairly straightforward in some ways. In another way, it's kind of tricky. So let's take a look at each of these intercepts first. I think these intercepts tell a lot of the story of what's going on here with the polynomial. And for each one of those things, I want to talk about the factor that produced it. If you remember from class, when you have a negative intercept, it's like the sign flips. It's not quite exactly the same. What you're really doing here is you're saying, okay, x equals -3. Let's get that 3 over here, which makes x plus 3 equals 0. Okay, that is the factor for this one. Now, it would be a little different if you had fractions. You'd have to be careful about those. So it's not quite an exact sign flip. And we'll see how that works with this next one. See this guy right here? Well, that's x equals, looks like -3 over 2. So I'm going to move that over by doing multiplication. I'm going to say 2x equals -3, and then that's going to become 2x plus 3. That's my factor. You could also say it's x plus 3 over 2. That would work fine. It would have some effects later on. We'll get to that later. So this factor right here I'm going to write as 2x plus 3. And I have a preference for writing these things without fractions. The next one right here, that might look a little weird, but if you think of it this way, as x minus 0, right? As if you had x equals 0, you subtract the 0 over to the other side, you get x minus 0 equals 0. That's your factor. Now, you don't have to write it as x minus 0 because that's kind of silly looking. You could just say it's a factor of x, right? That would be fine. That's usually how we write these things. We would say that's a factor of x right there. And then the last one, let's just clear some space here. The last one over here, that's just going to be x minus 2 by the same exact method. Now comes the exponents. The exponents are even exponents when you have a bounce. And they're odd exponents when you have a cross. So let's do that. Let's make even exponents of 2 wherever I see a bounce, and odd exponents, in other words 1, whenever I have a cross. So that's done. And now all we have to do is we have to multiply all these things together. So here's my equation that I'm building. F of x equals, leave a little space here, x plus 3 squared, 2x plus 3 not squared, x squared, and x minus 2 not squared. So that's my equation. And there's one missing part, which is that there could be something out front that I'm multiplying it by. I'm just going to call it a. I don't know what a is, but a is not x. A is not like x minus 5 or x plus 2, because those x-intercepts have all been accounted for. A is going to be a number like 7, or a quarter, or a negative something. And I don't know what that is until I take one last step. And see this dot right here? That has a non-zero y value. You have to grab something on the picture with a non-zero y value. It doesn't matter if it's a y-intercept or just some random point out in the middle of space. As long as it has a non-zero y, you're good to go. So what I'm going to do is I'm going to take the y value of it, which was -16, and I'm going to plug in all the rest. A is still a. I don't know what a is. But all these x's, those become 1. Because if you look at that picture, that was the x location of that point. So all I'm doing is I'm replacing all my x's with 1s. And that looks like it's really busy, but watch how quickly this is going to simplify. I get -16 equals a times 4 squared times 5 times 1 squared times -1. Okay, simplify it more. We get a times 16 times 5. The 1 squared I'm not going to bother writing. Times a -1, well, that just pops out front as a negative sign. Okay, so this is going to turn into -16 equals -80a. Or in other words, -16 over -80 equals a. So now you can say, well, that means my a equals 1 over 5. And that number, that 1 over 5, is not the answer to the whole problem, but you would plug that back in the beginning, right? Where it said a in the beginning, you would now stick 1 over 5.